All right. Welcome back to our technical series. This is going to be a little awkward, obviously, um, but we're going to go down um, a little ways into the rabbit hole of roll centers. Um, in order to do that, you need to start by measuring your car. Um, I don't want people to be intimidated, and I think it's a good exercise to just do on your own. But it is helpful if you're somebody who has your car taken care of at a shop. Get a knowledgeable shop that has a good flat plate to check your car over. Um, there are differences from chassis to chassis and just from wear and tear. So it's good to know. That information will be useful later as well. But for this purpose, my garage is really messy right now, and we're out here in my shed. Um, so we'll just pretend that this is a level surface here. A good way to check your surface for level, when we're for the purpose of this, we're not necessarily too concerned with front to back level, but we're concerned with side to side level. If you wanted to check an area of your shop floor, maybe dam it up with some Play-Doh or something like that. Pour some water and then take a ruler and check different depths and maybe note what the depth differences are. And since water seeks its own level, that's a poor man's way to calibrate your floor, so to speak. Um, anyways, another thing that's critical to this that mine is currently MIA is a plumb bob. Um, Plumb bob's basically a weight with a point on it that you can attach a string to. And what that would do is what we would start with is um, our pivot points. See this bolt here? Just to make sure we got the center, we're going to draw lines connecting the opposites. And so the center is going to be right there. Obviously, it's pretty easy to tell, but so we would drop a plumb bob down from here. Okay, I hold the string in the middle, let it fall where it does, and then I would recommend a pencil rather than a Sharpie. A little more accurate and makes the wives happy too, um, as opposed to marker on your floor. But I just make a mark right here where the plumb bob falls. Okay, this mark we're concerned about it in this direction more so than this direction. Okay, so just make a line right there, and we're gonna write. This is the upper inner. Okay, so now we've qualified that. Same thing here. We would make a mark down, and we go lower inner. Okay. I would also just make a mark where the frame is. Frame. Okay. Um, and so on. So you do all that stuff. I have a center mark in my frame right here. Okay. Some people don't have that. The way you would find where your center mark is. Okay. Um, you really after basically where the load is carried. So these where the shock bolts here. So I would be looking at this, and the same thing on the other side. I'd also compare my lower inner, and the center of those is going to be the center of your frame. Mark that, and that the center of your frame, okay, over here at ground level is going to be 0, 0. Okay, we're going to do X, and then Y is going to be our vertical height. All right, so we've marked our X in a few of these, and then we'll just take a ruler and connect the dots, as in go from your mark on the ground to the center of the bolt, and then look at where it lines up. Okay, this one's saying right at 5 1/4. I ought to stop right now. Obviously, we don't have weight in the car, but you should do this as raced, as loaded. Probably a half a tank of fuel and driver in the car. Get your air pressures hot to hot tire pressure and go from there. But so 5 1/4. So I would actually write down 5 1 4. Okay, would be my 5 1/4 for my vertical. Okay, and I do that. I'm looking at the lower pivot point, the upper pivot point. I would also be doing this for the outer pivot, lower pivot point, the outer upper pivot point. While you're measuring, it's also very convenient to know your shock location. That can give you a lot of information down the road. We also then want to locate the center of our tire, okay, in the X direction. And so anyways, we would do this on this corner, we'd do it on that corner. We do the same thing at the front of the vehicle, okay? Keep in mind right now, I've only got marks and I've only got my vertical distance, okay? What we then do is we would take our chassis center line for the back and our chassis center mark of the front, and we would use a straight edge connect the two. Okay, this is the center of the chassis. No matter what else you're measuring, this is the center of the chassis. Okay, so from there we would get our X coordinates for all these marks by then taking a square, because we would be measuring off of chassis center line, okay, and we could slide our square up and back, and we would just go where it intersects. So for example, this lower pivot point where we measured it was 5 1/4 up. This is measuring at right at 6 1/2. Okay. So now when I go to put it in software, or if you're graphing it on the side of a barn or your wall or whatever, the coordinate would be 6.5, 5.25, okay, and 5.25 up. Now you've got a center for that pivot. Do the same thing for that, and obviously there's a lot of boring stuff involved with that, but know all that, and mark all that stuff. Also, it's good to note where you will also need to know where the center height of the axle is, okay, and where the center of the wheel is in the X direction, okay. So the height of the axle in the Y, where the wheel bolts, and then the center of the wheel in the X direction, okay. And that'll get you what you need in order to get started. Seems really time consuming. Once you get a hang of things and just kind of the tools out and a procedure for it, your first corner will take you a little while. After that, it probably won't take you but maybe 20 or 30 minutes to do the rest of the car. Pretty simple stuff, and if you can measure to cut lumber dimensionally, you can do this. With an irregular floor, you get some accuracy issues, but it can also still point out glaringly big discrepancies, I should say. Again, good shops will do this just as a matter of regular inspection on chassis. If you don't feel like taking this on, it is good to hire a shop to do this and have them look at it. Again, it's just good information and a good maintenance record to do. So that's part one. Stay tuned for part 2 and part 3. one last thing I'd say is, do not assume that all cars of the same make and model have the same geometry. Okay, not every Crosley 40 is going to have the same dimensions as every other Crosley 40. Things happen; they've been used. In our examples, I'll compare two Zinc Z10Cs, and there's so many discrepancies in the pickup points. I've yet to see two Z10s that have the same combination of pickup points on them. And again, most of this stuff would change year to year, and or people assembling their cars together. Take a front suspension, for example, and through the years, not necessarily through bad intent, people would be, well, how many washers were between the Heim joint and the spindle? And so, sometimes they'd be like, oh, well, I'm pretty sure there were two there. Well, that makes a difference because now it moved your roll center when you did that. So something to be aware of, and something to, again, measure it on your car. Thanks, and stay tuned.